Hey, AP Computer Science principal students. First, let me say hello. Hope you're doing well. Hope that on beautiful days you are getting outside and enjoying the nice weather. Congratulations, you have finished the programming unit in code.org and for the year, really. But now it is time to apply what you have learned. And I'm doing this video today because basically, if we were together, I would be spending an entire class period, yes, 88 minutes, describing the next task that you need to do, and that is the Create task, which is part of the AP College Board requirement for this class. And since it takes 12 hours worth of time, it's also always been part of the requirements for my grade book as well. So whether you were planning to take the AP exam or not, you do need to do the Create task and do it to the specifications that are outlined by the College Board. So I am actually going to spend probably about 4 or 5 of our online sessions. It's going to seem excessive, but I promise you it is not, because you need to be prepared before you start the task. I will spend 4 or 5 sessions with videos and documents for you to look at, samples, things to kind of point out tips as to how you should complete this task. Because once you get started on the Create task, making your own program and then showcasing it for the College Board, I cannot help you. I cannot give you feedback of any kind. If we were in class together, I could give you technical help, like if you were having trouble with your computer or whatever, but I cannot look at what you're doing and say, yes, that looks good, or no, that's not good, you should improve this or that. I basically can just guide you through the process of doing the project. And so that is what I'm going to continue to do through virtual learning. Today, from this video, you will be getting credit for listening and following along and just getting to know what the project is about. So some of you might be wondering, especially if you are signed up to take the AP exam, what's going on with that, with us being home? So here's the deal. The AP College Board has decided for this AP class, they are canceling the multiple choice section. There will be no multiple choice test. You still get AP credit if you complete the 2 tasks and achieve a passing score on the Explore task and the Create task and upload them to the digital portfolio, as we were going to do anyway, but you will not have to sit for the multiple choice exam. So they have also extended the deadline for the Create and Explore task to be uploaded to the digital portfolio. It was supposed to be April 30th, but it is now May 26th is the deadline to submit these tasks. So when you, like tomorrow morning, I'm recording this on Thursday for you guys to see on Friday. Tomorrow morning, when I post this to the classroom, you will be getting a description of the task, a calendar of suggested timeline, including what we're doing today and going forward, and some things to think about. You actually don't have to do any work. You just have to watch the video, read along the task, and then answer some questions on a Google form. There's no programming you're going to do today or anything like that. So at this point, I'm going to just show you the timeline calendar that I created for a day. Let's see, I want to switch to that. I got to stop. Okay, I got to switch to the other tab. Okay, so here is the calendar. We are here Friday the 27th. I am introducing you to the Create task. We're going to read through the task thoroughly, the description of it from the College Board. We will spend the 2 more weeks prior to spring break just preparing to start the Create task. We probably would not have spent this much time if we were in school and we still had the deadline of April 30th. But since we have the time and we don't have anything to review for after that, like the multiple choice exam, we're going to take the time to make sure you are well prepared to do this task correctly, because this is what your AP exam score will be hinged upon, how well you do these tasks. I think you did a pretty good job on the Explore task. I had looked at them and graded them already, so now it's just a matter of doing a really good job on the Create task. So you'll see that we're going to focus on some different aspects of it that tend to be maybe the lesser understood aspects of the task next week. And then the following week, we're actually going to read the scoring rubric and look at samples and how they did well and did not do well, so that you don't make the same mistakes or you emulate the ones that are good. All right, so then there is spring break. We will not be doing any online learning during spring break. When we return from spring break, this is pretty much the same as last year. My students had all of spring break to think about what they were going to do for their Create task. And as soon as we got back from spring break, just like we did for Christmas break with the Explore task, we got started and we got it done. Let me switch tabs here. All right, so I'm about to open the Create task official description document. It has not changed in a couple of years, so the fact that it's labeled 2017-18, that's okay. And I just want to take a look at it with you. Let's see, Create task, official description. Okay. Here it is. This is called Create Applications from Ideas. The overview is, and I'm going to read this. If you want to just read it to yourself and kind of skip to the end of the video, I can put a note in the Google Classroom post about where you should pick up to just kind of finish the video. I'm not sure. Stop. But this is what I would do in class. I would read the whole thing with you just to make sure that it got out to you. Very important. So programming is a collaborative and creative process that brings ideas to life through the development of software. Programs can help solve problems. They can enable innovations or express personal interests. In this performance task, you will be developing a program of your choice. Your development process should include iteratively designing, implementing, and testing your program. You are strongly encouraged to work with another student in your class. Now, that's something I'm going to talk to you about because these are different circumstances. So at the end of this, after we've gone through the document, I will address the cooperative portion of this. I'll just keep reading for now. Okay. Please note that once this performance task has been assigned as an assessment rather than as practice, you are expected to complete the task with minimal assistance from anyone other than a collaborative peer. For more clarification, see the guidelines for completing the through course performance tasks section. You will be provided with a minimum of 12 hours of time. In this case, class time is virtual learning time. It's your time at home. You will be given 12 hours to complete and submit the following. Number 1, a video of your program running. Number 2, you must submit the individual written responses about your program and development process. And number 3, you will submit your program code. Scoring guidelines and instructions for submitting your performance tasks are available on the AP Computer Science Principles course homepage. Don't worry about non-traditional classroom environments. Our environment is you working at home on a Chromebook instead of in my classroom with me. The performance task requires you to develop a program on a topic that interests you or one that solves a problem. During the completion of this performance task, you will iteratively design, implement, and test your program. You will provide written responses to prompts about your program and specific program code that are significant to the functionality of your program. It is strongly recommended that a portion of the program involves some form of collaboration with another student in your class. For example, in the planning, designing, or testing, debugging part of the development process. Your program development must also involve a significant amount of independent work writing your program code. In particular, algorithms and abstractions that you select to use as part of your written response to describe how the program code segments help your program run. You are required to independently develop an algorithm that integrates two or more other algorithms, and that is fundamental for your program to achieve its intended purpose. You are required to develop an abstraction that manages the complexity of your program. You are required to create a video that displays the running of your program and demonstrates its functionality. You are required to write responses to all the prompts in the performance task and submit your entire program code. Your program must demonstrate a variety of capabilities and implement several different language features that, when combined, produce a result that cannot be easily accomplished without computing tools and techniques. Your program should draw upon mathematical and logical concepts, such as use of numbers, variables, mathematical expressions with arithmetic operators, logical and Boolean operators and expressions, decision statements, iteration, and/or collections. Your program must demonstrate the use of several effectively integrated mathematical and logical concepts from the language that you are using. It must demonstrate implementation of an algorithm that integrates two or more other algorithms and integrates mathematical and/or logical concepts. And your program must demonstrate development and use of abstractions to manage the complexity of your program. For example, procedures, functions, abstractions provided by the programming language, APIs, etc. The submission requirements are as follows. Number 1, your video. You must submit a video of the program running in one of the following formats: MP4, MWV, or AVI, or MOV format that demonstrates the running of at least one significant feature of your program. Your video must not exceed 1 minute in length and must not exceed 30 megabytes in size. I will say right now, we learned from the Explore task that if your video is more than 59 seconds, even if it is 60 seconds, it may not upload. So try to keep it under 1 minute. You must submit written responses. Submit one PDF file in which you respond directly to each prompt. The prompts will be following on the next page. Clearly label your responses in order, and your response to all prompts combined must not exceed 750 words, exclusive of the program code. And here are the prompts that you will have to answer. Your written responses. 2A, the prompt says, provide a written response or audio narration in your video that does all three of the following things: identifies the programming language, identifies the purpose of your program, and explains what the video illustrates. That's your first prompt. We will talk individually about each of these written responses in our next few blocks of preparation time. 2B, describe the incremental and iterative development process of your program, focusing on two distinct points in that process. Describe the difficulties and/or opportunities you encountered and how they were resolved or incorporated. In your description, clearly indicate whether the development described was collaborative or independent. At least one of these points must refer to independent program development. Prompt 2C, capture and paste a program code segment that implements an algorithm, marked with an oval in section 3 below, and that is fundamental to your program to achieve its intended purpose. This code segment must be an algorithm you developed individually on your own, must include two or more other algorithms, and must integrate, like sub-tasks basically, and must integrate mathematical and/or logical concepts. Describe how each algorithm within your selected algorithm functions independently, as well as in combination with others, to form a new algorithm that helps to achieve the intended purpose of the program. Prompt 2D, Capture and paste a program code segment that contains an abstraction you developed individually on your own, marked with a rectangle in section 3 below. This abstraction must integrate mathematical and logical concepts. Explain how your abstraction helped manage the complexity of your program. Section 3 is to capture and paste your entire program code into one document. And I have a tool that makes this easy to do. And in fact, the tool provides the ability to do the next few things, which is mark an oval around the segment of program code that implements the algorithm created for your program and integrates other algorithms and integrates mathematical and or logical concepts. You also need to mark your code with a rectangle around the segment of code that represents an abstraction you developed. And then you need to include comments or acknowledgments for your program code if any of it has been written by someone else, or if you've taken images or sounds from somewhere else, you need to put those in the code as comments. Okay, that is the official description. Okay, you can finish reading this document on your own. It's posted on the College Board website under this class exam description. It is posted here on my Google Classroom, and I also have some brainstorming questions for you. So I would like to open that. Darn it. The brainstorming questions. Let me get that open in this. Okay. You might be thinking, what kind of program am I going to write? First of all, you may be wondering about the collaborative aspect of this project. And if we were in class, I would be telling you, you may choose a partner and work together on one program. But if you were going to do that, you need to split up the work, not just have one person write the program and the other person sit there and look on. You would actually have to split up the work, designate and delegate one person to do this portion of it. Like say, I will write the function that calculates this. I will write the function that calculates that. Split it up and then put it back together. You would each have to have an individual portion that you worked on by yourself. Now, obviously, since we're all working at home, it will be easier to just work by yourself and make your own program. But if you happen to have someone that you, like, let's say we had a brother and sister. I had two brothers in the same class. If they wanted to work together because they live at home together anyway, that would be fine. And you just follow the instructions for collaborative programming. I would assume most of you are just going to do this by yourself. If you wanted to get it done somehow with a partner, virtually learning from home, doing your own communication over whatever medium you want, and then being able to share your code back and forth and put it back together at the end, go be my guest. You're allowed to work with a partner and create one project that you both describe separately in your written responses. But within that project, it cannot be just one person or both of you sitting together and working on everything together. It needs to be split up into, I do this part and you do that part. You have to have your individual portion. Okay. And then you need to describe that differently in your written responses. Okay, so here are some ideas for projects that you could do for your Create task. Some of you may already have a great idea. You've been thinking about this ever since we started programming, and you're thinking, I think I know what I want to do. And that's wonderful. I hope that there are those of you out there who already have ideas. If you don't have an idea, this is to get your brain thinking. You've got about 2 weeks to mull it over and decide what you're going to do. So first question, Could you possibly create some kind of a useful tool based on your interests, what you're involved in, your sports clubs, job, family members, hobbies? Could anyone that you know benefit from some sort of an app? Maybe it's just an app that conveniently puts a bunch of things in one place that involve calculations. For instance, I have one as a teacher where I created an app to help predict what a student will get for the year. If I know, 3/4 of their grades and they're trying to achieve a 90 for the year, what do they need to get on the last quarter in the exam to get that? I have made an app like that for myself because, with the whole quarter exams being worth different amounts in math, 6%, 6%, 8% type of thing, it's been a little bit confusing to be able to just give an answer like that. So here's the app that I created. You can plug in the grades you already know. Let's say you already have an 85 and an 80 and a 95 and a 87, and you have a, say, 98. You could basically calculate what you got so far is an average of 65 if you don't do anything for the last quarter. But if you, let's say, maintained a 90 for the last quarter, you now have an 83. If you change this, you could just play around with it and plug things in. Let's say you got a 90. What would be your score? Oh, that would be enough. I need a 90 on both. Or, how low can I go? Plug something in that's smaller. Ooh, even with an 85, I've still got a 90. So this is the app that I made in code.org because it was useful to me. So you can check that out. Okay. Secondly, you could make a game. You might want to read this. Games could be all kinds of varieties. I'm going to show you some samples that come from the College Board, some that come from code.org on other days that you can kind of look at as inspiration, not to take, not to plagiarize, not to copy and then just change a few things. That will not be acceptable. But if you want to make a game, some sort of, even if it's a game that exists already, but you want to make a custom version of it with a theme that you like, just to kind of have the challenge of recreating that game for yourself, that's a great possibility. You actually could expand upon an earlier project that we have done in code.org, and I have a list here to take you straight to those like kind of end of the unit projects and just a description of each one. But if you expand upon one of the code.org projects, just know that the readers of the AP exam are very familiar with these things. They see them all the time. These are available to thousands of students, and they would be looking for you to do a really extensive addition, adding features, making it, much more intricate, or adding a lot of functionality beyond what was in the lesson, enough that you don't have to refer to what was in the lesson, that code. You don't have to refer to that code in your written responses. You would have to add extra features beyond that you could be describing in your written responses. So that's a caution. If you do kind of start with something you've already done and go from there, you have to really beef it up, really make it much better. Here's a great idea that I love. You could think interdisciplinary. Think about another topic besides computer science that you enjoy, maybe a class that you're really into, and you could make some sort of an app that connects to that class, maybe an interactive tutorial or visual demonstration, a simulation of a science concept, a math formula that you want to automate that you can just plug numbers in and it will spit out the answer, that kind of thing. Think interactive, interdisciplinary connections. That's another idea. You could create a simulation, basically model with, randomness, perhaps. mathematical calculations, model some kind of phenomenon, and use the power of computing to simulate large-scale results like we did with the dice rolling. Something that would be difficult or impossible to do by hand. Maybe you could even make an animation of some sort of simulation, depending on what it is. You could do something that's purely artistic. It just makes a beautiful design, but remember the Design a Scene project? If you do that, you just have to make sure that the code you write for it provides you enough depth and complexity to be able to answer the written responses, that you would have algorithms within algorithms, you'd be using mathematical concepts, you would be packaging up subtasks as functions, so you would have an abstraction to write about. So that's another possibility. Okay, I think I may have said enough for today, and you're going to be answering some questions throughout this video and at the end of the video, just to get credit for listening to this, and start to think about it. That's your job from now till the end of spring break, is start to come up with an idea and pay attention as I describe all the little details of how you will complete this project. Okay, I hope you have a great weekend, and I'll talk to you again on Tuesday.